Assalamualaikum warahmatullahi wabarakatuh. Today, me, Aiman bin Zulfekar, along with my friends Muaaz bin Abdul Ghani, Muhammad Asyraf bin Saipol Anwar, and Hazeeq bin Ahmad are going to present our presentation regarding the application of linear and quadratic function. So, we are going to explain the application of linear and quadratic function towards the demand and supply function, the market equilibrium point, the cost and revenue function, the break-even point analysis, and maximum and minimum. Okay, firstly is supply and demand. So, supply and demand in economics is a relationship between the quantity of a commodity that producers wish to sell at various prices, which we can call this as the supply, and the quantity that consumer wishes to buy, which is the demand. So, the price of the commodity is determined by the interaction of the supply and demand in market. In equilibrium, the quantity of a good supplied by the producer equals the quantity demanded by consumers. So, as we can see here, this is the supply and demand curve. So, in the curve, if the price increases, the supply will also increases, but the demand will decrease. So, this is the two curve between the demand and supply, and there will be an intersection between the both equation, and we will call it as the equilibrium. This is the equilibrium, the middle point. Okay, so I will give you an example on how supply and demand works in a quadratic function. So this is the equation. We can see there are given two equation, which is the demand and the supply equation, and the x represent the quantity in units of 1,000. So for the first question, it says that determine the quantity demanded when the price is $10. So it asks for the quantity demanded. So we have to use the demand equation. So replace P with the 10, and we solve it. We got the demand is equal to 5,000 units. For B, determine the price at which the supply will provide 3,000 units. So the 3,000 here is equal to 3. It will be simplified, and we will use the supply equation because it says here is the supplier, the price at which the supplier. So we have to use the supply equation. So replace x with 3 and find the P. We get $66. And C, the main thing about the supply and demand is to determine the equilibrium, quantity and price. So we equal both the equation. So here we have P equals to P, the demand and the supply. So we have we combine it to 60 minus 2x the power of 2 equals to x the power of 2 plus 9x and plus 30. From this, we will have two answers, which is x equal to -5 and x equals to 2. We will choose the 2 because -5 is not definable in demand, so there's nothing negative in this graph. So we have used the 2, the x equals to 2, and put it back in the equation, and we will get the y is $52. So hence we know the market equilibrium between the supply and demand is x equals to 2,000 units, and P equals to $52. So that's all for this topic. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ammar bin Kamal. Today I want to talk about what is the break-even analysis. Okay, a break-even analysis is a financial calculation that weighs the cost of a new business, service or product against the unit sales price to determine the point at which you will break even. In other words, it reveals the point at which you will have sold enough units to cover all of your costs. Okay, next I want to talk about how break-even analysis works. Okay, a break-even analysis is a financial calculation used to determine a company break-even point, or we call BEP. It is an internal management tool, not a computation that is normally shared with outsiders, such as investors or regulators. However, financial institutions may ask for it as part of your financial projection on a bank loan application. Okay, the formula takes into account both fixed and variable costs relative to unit price and the profits. Fixed costs are those that remain the same no matter how much product or service is sold, Example of fixed costs, we can include facility rent, mortgage, equipment, costs, salaries, interest rates, and other more. Okay, for the variable cost, and it rise and fall according to the changes in sales. Example of variable cost, we can include directly direct hour labor payroll costs, sales commission, and the cost of the raw material. Variable costs are the sum of the labor and material costs it takes to produce one unit of your product. Okay, for the how we can get the total variable cost is by multiplying the cost to produce one unit by the number of units you produce. Okay, for the contribution margin, we have the formula which is the sale price minus with the variable cost. Okay, the average variable cost is calculated as your total variable cost divided by the number of the unit produced. In general, lower fixed costs lead to the lower break-even point, but only if the variable costs are not higher than sales revenue. Okay, now the formula of the BEP, or we call break-even point. The formula of the break-even point is the fixed cost divided with the sales price per unit minus variable cost per unit, and after that we can get the BEP point. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. So we can continue with my topic that I will present is market equilibrium. So what is market equilibrium? Market equilibrium is a situation where the price at which quantities demand and supply are equal, which is we can say a supply equal to demand. So when the market is in equilibrium, there is no tendency for prices to change. So in the market system, it is driven by the two forces, which are demand and supply. So this is because these two forces play a crucial role in determining the price at which a product is sold in the market. So the price is determined by the interaction of demand and supply in the market. According to the economic theory, so the price of a product in the market is determined at the point where the force of supply and demand meet, and the point where the forces of the demand and supply meet is called equilibrium point. So for the formula for the market equilibrium is the QDP equal to QSP, which is we can say QDP is the quantity demand at price P, and the QSP is the quantity supplied at price P. So next we go to the determination of market price. As we mentioned earlier, the market equilibrium price of a product is determined at the point of intersection of demand and supply. However, it is important to understand how the price is determined. So we can give an example such as when the price is 600, the demand for fans is 80,000 units, while supply is only 55,000 units. So this indicates that there is a shortage of 25,000 fans in the market. As the result of this shortage, the seller tries to increase their earning by raising the price of fans, and the consumer will be willing to purchase at the price quoted by the seller due to the shortage of fans. So this leads to an increase in the profit of the seller, which will in turn improve the production of fans. As a result, the supply of fans increase, and the process of the increase in prices goes on till the price of fan reach to 700. So when the price is 700, the demand is reduced to 70,000 fans, and while the supply is also increased to 70,000 fans. So this equilibrium is reached, and this will lure the consumer to buy more due to reduction in the price of fans. As a result, as we can see, an increasing in buying, and the equilibrium price will be 300. So we go to the type of shift in market equilibrium. So there was two type of shift in market equilibrium, which is shift in demand curve and shift in supply curve. So what is shift in demand curve? Shift in demand curve is as we can say, is a demand curve shift. An increase in quantity leads to an increase in the equilibrium price. So next is shift in supply curve. We can say that is an increase in quantity result in an increase in the equilibrium price too. So there's a complete case of shift in equilibrium. So what effect do simultaneous variation in the supply and demand curve have on the equilibrium point? So the impact on the equilibrium point is determined by the magnitude of the shift in the demand and supply curve, which is the equilibrium price decrease and output rises when the supply curve shift more than the demand curve. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muaaz bin Abdul Ghani. So today we continue about the cost and given function. So first we go to about the cost first. Cost has two types, fixed cost and variable cost. So in the formula, how to get the total cost is fixed cost plus variable cost, which has been multiplied by the number of units produced. Next, revenue function. Revenue function is equal to the number of units sold times the price per unit. To obtain the revenue function, we must multiply the output level by the price function.
Finally, last but not least is the maximum and minimum in quadratic equations. Before we explain regarding the max and minimum in quadratic, we first need to understand what parabola is. So, we are going to use this example to explain this. Parabola is the shape that is formed in the graph of a quadratic function. As we look at this example, this is what we call parabola. So the point vertex there is the point of symmetry where each side of the parabola is equal. So as we know, the quadratic equation is fx equals to x to the power of 2 plus bx and plus c. If the parabola opens up, meaning that it is a over more than 0, the vertex is the lowest point on the parabola. We say that the k here is the minimum functional value of f, or the absolute minimum value of f. If the parabola opens down, like the right one, meaning that the a is lower than 0, k is the maximum functional value of f, or the absolute maximum value of f. Maximum and minimum functional values are called extreme functional values. So this is an example in quadratic function about the maximum and minimum. So we have here 2x to the power of 2 plus 4x minus 2. There are two ways to calculate the maximum or minimum value. So the first way is by formula, and the second way is by vertex form. Okay, for the formula, okay, since the a here is more than 0, the parabola will be opened up, and it will call the minimum value. So the vertex of x, the formula is the vertex of x equals to negative b divided by 2a. So here we can conclude that the a is 2 and b is 4. We get the vertex of f is negative 1. So we put back the negative 1 into the equation, we get the minimum value is negative 4. For the second method is the vertex form. So using the general form of equation, we change it into the vertex form, which is here is fx equals to a x minus h the power of 2 plus k. So the h here is the x of the vertex, while the k there is the y of the vertex. So we turn the standard form into the vertex form here, we factorize it, and we get 2x plus 1 the power of 2 minus 4. So here we get the same as before, x equals to negative 1 and y equals to negative 4. We get the minimum value is negative 4. So that's all from us. Thank you for listening.